Hi there, my name is Elizabeth Beaton, and I'm a second-year master's student in the School of Forensic Science at Oklahoma State University's Center for Health Sciences, and my research is on the degradation of beta-actin in blood and semen stains. So piecing together a crime scene is one of the most significant components of any forensic investigation, and estimating the age of biological stains at a crime scene can be crucial to the case. Several studies have demonstrated a correlation between the degradation kinetics for mRNA transcripts present in dried body fluid stains aged for varying amounts of time. The relationship between the age of a sample and the state of degradation of many transcripts can be exploited to estimate the age of an unknown crime scene stain. In this laboratory, preliminary work has demonstrated that the 5' and 3' ends of many mRNA transcripts degrade at different rates during aging of body fluid stains. Specifically, the 5' end will degrade faster than the 3' end. So the purpose of this study is to map the degradation of the entire ACTB transcript, which is 1,812 base pairs long. And we're going to be mapping that in dried blood and semen stains, and we're going to determine if variances in degradation sensitivity are uniformly distributed along the length of the molecule. We will also evaluate the kinetics of ACTB, mRNA degradation, in dried blood and semen stains to determine whether there are any tissue-specific differences in transcript degradation. So we started by designing qPCR primers from NCBI to span the entire length of the ACTB transcript to direct the amplification of about 100 base pair qPCR amplicons. Blood and semen RNA was extracted from collection cards. Since this was only our preliminary test of the primers, time was not a factor for now. For each primer site, we separated the blood and semen stains into 3 categories. One blood and one semen sample was purified through a zymal spin column, followed by reverse transcription to cDNA. Another blood and semen sample was purified through a zymal spin column as well, but this time we added an extra purification step to remove any remaining inhibitors, and this sample underwent reverse transcription to cDNA as well. As for the third sample, a blood and semen sample was purified through a zymal spin column but did not undergo the extra inhibitor removal step, nor did it undergo reverse transcription. So our next step was performing real-time qPCR using the QuantStudio 5 to determine the CQ values. And for each new primer, we also ran efficiency testing through qPCR. So this is just a depiction of all 18 of our designed forward primers along the genome, and this shows the primer sites where we will be tracking the degradation. And then this is a graph of our preliminary testing of our first set of primers. So you notice the 3 categories between the blood and semen. There's the regular blood, there's a blood that was purified with that extra step, and then there's blood no RT, so no reverse transcription, no cDNA. And then it goes for the same as with the semen. And the use of cDNA and the added purification step really makes a difference in our CQ values, which is beneficial in the long run to provide an accurate estimate of sample age. So you can see the huge difference between the no RT and the purified blood, and even between the regular blood and the purified blood as well. And same for semen. So as I said, the addition of reverse transcription and an extra purification step is crucial to achieve the best results. And now that we have our qPCR primers and efficiencies, we can now begin our actual study of ACTB degradation in blood and semen stains, which we will be storing for increasing periods of up to 8 weeks. The findings of this study will contribute to the knowledge that will be needed to apply this technology to estimate the age of biological samples found at a crime scene. And I just want to thank Dr. Allen and Dr. Fu for their assistance and guidance throughout the research process. And then this is a list of my relevant references, and that is it from me. I hope everyone has a great rest of their week, and thanks for watching.